You hear it everywhere these days, right? Scale AI, bigger models, more data. Like it's the only way to make AI smarter is to just, well, supersize it. But what if I told you there's another way?
Oh, I'm intrigued. What if instead of just making AI bigger, we made it think harder?
Exactly. That's what we're diving into today, the world of test time computing, our main source. This super interesting paper called Test Time Computing from System 1 Thinking to System 2 Thinking.
Ah, yeah. System 1 versus System 2. I love that framework.
Right. So for anyone just tuning in, the paper breaks down the two main ways we think, us humans and AI. System 1, that's fast, intuitive, like recognizing a face.
Like if you're driving and you slam on the brakes to avoid an accident, you don't really think it through, you just react.
Exactly, pure System 1. But
Yeah.
then there's planning a trip, for example. That's System 2. Slower, more deliberate.
Yeah, weighing your options, making lists, that kind of thing.
Yeah.
So where does AI fit into all of this?
That's the game changer. For a long time, most AI has been like a superpowered System 1. Great at specific tasks, but not so good at handling new situations. Think about it. Most AI is trained once, and that's it. It just uses what it learned forever.
Right, which can make it kind of brittle. Like if the world changes even a little bit, it can get thrown off.
Exactly. But this new research, it's showing us how we can make AI think more deeply, engage that system too, during the testing phase, even after it's been trained.
Wait, hold on. You're saying we can make AI actually reason during testing?
That's what this paper is all about. And that's our mission today, to understand how test time computing works for both those System 1 and System 2 models. We'll look at the different approaches and see why this might be the key to, well, truly intelligent AI.
Sounds like a fascinating deep dive. I'm ready to jump in.
Perfect. Well, let's start with the System 1. You know how you study for a specific test, but then you get thrown a curveball, like a new
Uh-huh.
format?
Mhm. Totally throws you off.
That's what test time adaptation, or TTA, does for AI. It helps it adapt on the fly to stuff it wasn't specifically trained for.
So TTA is like giving the AI a crash course right before the test
Yeah.
to help it adjust to the new format.
You got it. But it's not quite that simple. In the early days of TTA, they were actually updating the model's parameters during testing, like really changing it.
Oh, wow. I can see how that would work for things like visual tasks. Imagine an AI learning to predict how an object will look when rotated. You could use TTA to fine-tune its predictions, even if the lighting or background changes during testing.
Yeah, that makes sense. But I bet that's not so easy with these massive language models,
Yeah.
LLMs. Imagine trying to tweak billions of parameters on the fly.
Yeah, no way. Directly updating an LLM during testing, that'd be a computational nightmare. So for LLMs, TTA has become more about like finding clever ways to guide the model during testing without changing its core structure.
So more like nudging it in the right direction without actually rewriting its brain, so to speak.
Exactly. And one way to do this is through input modification. That's where you play around with something called in-context learning, or ICL for short. You know how LLMs are surprisingly good at figuring things out if you give them a few good examples beforehand?
Yeah, like showing them how to solve a problem step by step.
Exactly. With input modification, you're basically giving the LLM the right kind of examples at the right time to, like, point it in the right direction.
Okay, so it's all about providing the right cues to guide the LLM's reasoning.
You got it. Researchers are using all sorts of techniques to find those perfect examples. Some even have the LLM generate its OWN examples. Can you believe that?
Wait, the AI is making its own study guide?
Exactly. And it's surprisingly effective. But there are other techniques too. What about representation editing? Have you heard of that?
It sounds kind of spooky, like we're manipulating the AI's thoughts or something.
Huh. Not quite mind control. Think of it more like, okay, imagine a GPS system. It can gently nudge you towards your destination without dictating every single turn, right?
Okay, yeah. So with representation editing, we're subtly influencing how the AI processes information, not forcing it, but guiding it.
Right. And that's led to some impressive results. For example, folks are using it to reduce harmful outputs from LLMs, like preventing them from generating offensive
That's
text.
huge. Shaping AI to align with our values, that's got to be a top priority. So we've got input modification and representation editing. What about that last one, output calibration? What's that all about?
Okay, so imagine the AI's done all this thinking, it's about to give its answer. Output calibration is like giving it one last chance to double check. We provide a little extra context or info to make that answer as accurate as possible.
So it's like a final proofread before hitting send on an important email. Make sure it's all good to go.
Exactly. It's all about helping the AI nail its performance. even if it wasn't specifically trained for that exact situation.
So we've got these three main techniques for TTA input modification, representation editing, and output calibration. It's mind-blowing how we can squeeze more performance out of these System 1 models without retraining them completely.
It really is, and it highlights the incredible potential of test-time computing. But wait till we dive into what happens when we apply these ideas to System 2 models, those deep thinkers. That's where things get really interesting.
Oh, I'm ready. Let's talk about how we make AI really think things through.
Welcome back. It's one thing to talk about the theory behind test-time computing, but seeing it in action, that's what really brings it to life. So let's shift gears a bit and explore some real-world examples, shall we? See how this stuff is actually being used.
I'm all for that. Last time we talked about all these cool techniques, TTA for System 1, all those reasoning strategies for System 2. But now, yeah, let's see some results. What's test-time computing actually doing out there in the wild?
Okay, well, how about we start with visual tasks? That's where test-time computing is, really making a splash. One example that always impresses me is something called test-time training, or TTT.
TTT. Rings a bell. Didn't we touch on that earlier? Something about actually training during the testing phase, right?
You got it. Might sound a bit counterintuitive, I know.
Yeah.
We usually think of training and testing as like separate things, right? But TTT kind of blurs the lines. It lets the model keep learning, even as it's being evaluated.
Okay, yeah, starting to come back to me. But how does that even work? Doesn't training usually need labeled data? Like tons of examples with the right answers already attached.
Right, which is why this is so clever. TTT uses something called self-supervised learning. Picture this. An AI is trained to recognize, say, different objects in pictures. But during testing, it gets hit with images with weird lighting or backgrounds, stuff it's never seen before.
I see where you're going with this.
With TTT, the model can actually learn from those unlabeled test images. It adapts to those new visual conditions all on its own.
Wow. That is wild. It's like the AI is constantly fine-tuning its vision even after its formal training is over. Kind of reminds me of how we humans adapt, right? We're always learning from our surroundings, even without someone telling us exactly what we're seeing.
Perfect analogy. And this whole adapt on the fly thing, it's a lifesaver in real world situations where your training data just can't cover every possibility.
That makes a lot of sense. So TTT is helping AI bridge the gap between that perfectly controlled world of training data and the messy, unpredictable real world. What other cool stuff are we doing with visual tasks?
Oh, plenty. There's another approach, fully test time adaptation, FTTA. This one's even more radical.
FTTA. Okay, that one's new. What makes it different?
With FTTA, get this, you adapt the model during testing, but no labels whatsoever. You don't even need to change the original training process.
Hold up, no labels at all. How does the AI even know what it's looking at? How can it learn without some kind of feedback?
That's the beauty of it. FTTA works by squeezing information out of the test data itself. One trick is to use the AI's own uncertainty as a learning signal.
Its own uncertainty? What do you mean?
Think about it. When the AI sees something totally different from what it learned on, it gets less sure of itself, right? Its predictions get less confident.
Yeah.
We can use that lack of confidence to guide its adaptation.
Oh, that's brilliant. Like turning the AI's self-doubt into a learning opportunity.
You got it. We're basically harnessing the AI's internal state to make it better. There are different ways to measure this uncertainty, but the point is, FTTA lets AI improve even with completely new unlabeled data.
That's seriously mind-blowing. Got any real-world examples of this FTTA in action?
Absolutely. It's actually showing a ton of promise for adapting machine learning models to different languages.
Languages? I thought we were talking about vision. How does this fit in?
Good point. This actually shows just how versatile these test-time computing ideas are. Imagine you've got a model trained to translate, say, English to French, but now you need it to go English to Spanish.
Yeah, you'd usually need to retrain the model on a whole new Spanish data set, right?
Traditionally, yes. But with FTTA, you can bypass that whole step. You feed it unlabeled Spanish text during testing, and boom, it adapts on the fly. Gets better at Spanish translation without ever seeing a single labeled Spanish example.
That's wild. It's like having a universal translator that can learn any language just by being around it.
That's the goal. And it's so important in a world where everyone's connected, right? We need AI that can handle different languages and cultures without skipping a beat.
It's a recurring theme we've been seeing. Test-time computing is all about breaking down the old limitations, making AI way more flexible. It can learn and adapt in ways we never even thought of before.
You're spot on. It's changing the game entirely.
Okay, so we've seen the magic happening with visual stuff, with languages. What about those big, powerful language models everyone's talking about, the LLMs?
Hmm.
How's test time computing shaking things up there?
Oh, that's where things get really interesting. Remember we were discussing in-context learning, ICL, where you give the LLM a few examples and it just figures it out.
Yeah, I love that. It's like the AI is learning from watching like a kid copying their parents.
Exactly.
Yeah.
And it turns out that test time computing is making ICL even more powerful.
Okay, now I'm really curious. How?
The tricky part with ICL is, well, finding the right examples to give the LLM. If the examples are bad or not really relevant, the AI kind of flounders.
Yeah, makes sense. Like giving someone a terrible textbook, they're going to learn the wrong stuff.
Precisely. That's where test time computing swoops in to save the day. Researchers are using techniques like similarity search to pull the most relevant examples from massive databases. So instead of humans handpicking examples,
We're using AI to pick what the AI learns from. That's kind of meta.
totally. And get this, some folks are even letting the LLM generate its OWN examples.
Hold on, the AI's coming up with its own study guide. Now that's next level.
It is. And it works surprisingly well. By generating its own examples, the LLM can really tailor them to the task at hand. But it's not just about choosing examples. Researchers are also using test time stuff to influence how the LLM actually processes information, how it thinks.
Okay, that sounds familiar. Is this where that representation editing comes back in? That subtle manipulation we were talking about?
Ding, ding, ding. We might not be rewiring the AI's brain completely, but we can gently steer its thought processes, nudge it towards better results.
So instead of forcing the AI to think a certain way, we're giving it a helping hand, like a tutor guiding a student.
You got it. And the results speak for themselves. For instance, this technique is helping to reduce harmful outputs from LLMs. Stuff like preventing them from generating offensive language.
That's amazing. So we've talked about choosing better examples, even subtly influencing how the AI thinks. But what about the AI's core reasoning abilities? Can test time computing actually make AI smarter, more logical?
Now you're asking the real questions. And the research in this area is seriously groundbreaking. Remember those 3 test time reasoning strategies we talked about earlier? Repeated sampling, self-correction, and tree search.
Yeah, the ones for making AI think harder, how are they being used with these LLMs?
Well, with repeated sampling, you can actually get much better results from an LLM just by running it several times and then picking the best answer based on some criteria.
So we're not just settling for the AI's first guess. We're giving it multiple tries to get it right.
Exactly. And there are different ways to choose that best answer. One way is to use another AI, a judge model, to score each answer based on things like accuracy, how well it hangs together, how much it sounds like human reasoning.
Whoa, an AI judging another AI sounds intense. But wouldn't running these massive LLMs over and over be crazy expensive computationally?
True, it can be. So researchers are finding ways to make this whole repeated sampling thing more efficient. One idea is to actually train the LLM to mimic this behavior so it needs fewer tries during testing.
So instead of just running it a bunch of times and hoping for the best, we're teaching the LLM to be smarter about its choices from the get-go.
Exactly. It's all about helping the AI learn from its own mistakes and identify what a good answer really looks like.
That's so cool. What about self-correction? How does that work with LLMs?
Oh, this one's really mind-bending. It's about giving the AI the ability to critique itself, take feedback, and then try again. And this feedback, it can come from a human expert, from special tools, from other AIs, even from the AI itself.
Whoa, wait, hold on. The AI is giving feedback to itself. Isn't that like a paradox or something?
I know, it sounds wild. But imagine, okay, you're an AI writing news article. You could have another AI model act as your editor, checking for facts, grammar, style, everything.
Yeah.
Or use a tool that looks for plagiarism. Make sure your reporting is solid.
It's like having a built-in fact checker and editor. Makes sense. That would make AI-generated stuff way more reliable. But how do we make sure the feedback is actually good, like accurate and helpful?
That's the key question. Bad feedback could make the AI worse, not better. So there's a lot of work going into developing better feedback mechanisms. We want to make sure the AI is learning from the best sources, right?
Makes sense. It's like with any student, the better the teacher, the more they learn.
Exactly. But even with good feedback, this whole self-correction thing is still a mystery. There's so much research to do, figuring out if it works for all kinds of tasks in all kinds of situations.
It's amazing how far we've come. AI that can learn from its mistakes, that can edit itself.
Huh.
What about that last strategy, tree search?
Tree search. That's where things get seriously interesting. Remember, it's all about systematically exploring all the different paths to a solution, like finding your way through a maze or planning a trip.
Yeah, like the AI is thinking several steps ahead, right? Like playing chess, considering all the moves.
You got it. And just like there are different ways to navigate a maze, there are different algorithms for tree search. Some go step by step, but for really complex problems, it's better to use something called heuristic search, specifically Monte Carlo tree search, or MCTS.
Wait, Monte Carlo tree search? Didn't we run into that earlier when we were talking about those visual tasks?
You have a sharp memory. It's actually a very versatile technique, works for all sorts of problems, from games to robots to language. And with LLMs, MCTS is showing amazing potential for boosting their reasoning skills.
Can you remind me how it works? I remember it had something to do with picking the most promising paths.
Right. So instead of checking every single possibility, MCTS focuses on the paths that are most likely to lead to a good solution. Think of it like a chess player who focuses on the best moves instead of trying every possible move.
So it's all about efficiency, right? Like the AI is learning to use its brain power strategically.
Exactly. And to make those smart choices, MCTS uses a value function to estimate how good each pass might be. It's kind of like the AI is developing its own intuition, learning to recognize which paths are likely to lead to a good outcome.
Wow, that's wild. It's like the AI is learning to prioritize its thinking, just like we humans do.
You got it. And as the AI explores these different paths, it gathers more data, which helps refine its value function. So it's constantly learning and getting better at making decisions.
This is all so fascinating. But honestly, part of me is still wondering if this stuff can work in the real world. Can an AI really do all this complex tree searching in real time, like for tasks where you need answers quickly?
Yeah, that's a valid point. Tree search can be computationally heavy, especially with large models and tricky problems. So researchers are working on ways to make it more efficient, things like pruning branches early on or exploring multiple branches simultaneously, to speed things up.
So it's all about that balance between exploring possibilities and doing it fast enough to actually be useful.
Absolutely. And as our computers get even more powerful, I think we'll see tree search become even more important for AI.
Well, all these test time reasoning strategies, they're truly impressive. We've gone from simple pattern recognition to AI that can actually plan and reason. It's really amazing.
It is. And we're just getting started. The research we've been talking about, that's just the beginning. There's so much more to explore, so many challenges, and so many possibilities to unlock.
I'm all for exploring more. What are some of the biggest challenges and opportunities for test time computing in the future? Where do we go from here?
The paper highlights a few key areas, and one that keeps coming up is this idea of generalization.
Generalization, right? We talked about that before. Making AI more adaptable, more like a human thinker that can handle any kind of problem.
Exactly. Remember, most AI models that are good at reasoning, they're kind of specialists, right?
Yeah.
Good at math, but maybe not logic puzzles, that kind of thing. But humans, we're way more flexible.
So the goal is to have AI that can reason across different domains, just like we can. That sounds incredibly ambitious.
It is ambitious. But researchers are on it. They're trying to design more general-purpose reasoning systems, train models on more diverse data, and even teach AI to learn new skills from just a few examples, like we humans do.
This is where I get really excited. Imagine AI that can handle anything you throw at it, from writing a poem to solving a complex equation, all with the same brain.
That's the dream. And it might not be as far off as you think. But before we get too carried away, there's another challenge we can't ignore. Multimodal reasoning.
Multimodal reasoning. Yeah, we talked about that earlier, going beyond just text, bringing in images, sounds, even videos.
Right. We use all our senses to understand the world, and if we want truly intelligent AI, it needs to be able to do the same.
It sounds so challenging, though. How do you even teach an AI to understand something as complex as a video?
It is definitely a frontier area, but there are some promising approaches. For example, researchers are combining language models, which are great at understanding words, with computer vision systems, which are great at understanding images and videos.
So it's like giving AI the ability to see and read at the same time.
Exactly. And that kind of integration is essential for so many applications, like self-driving cars that need to interpret their surroundings, or medical AI that needs to analyze scans and patient records.
The possibilities are endless, but with all this extra reasoning and data processing, how do we make sure it's all efficient enough for the real world? This must take a ton of computational power.
That's a key challenge. Efficiency is everything. And researchers are working on it from all angles, optimizing algorithms, exploring new hardware, the whole works.
So it's like a two-pronged attack, improving both the software and the hardware to make multimodal reasoning more feasible.
Exactly. And this focus on efficiency actually ties into another important research area, scaling laws.
Ah, yes, those again, the laws that describe how AI performance scales with model size, data, that sort of thing.
Right. We know that bigger models and more data generally mean better performance. But the question for test time computing is, can we find similar laws that govern the relationship between test time compute and performance?
So if we give the AI more time to think during testing, can we predict how much better it will get?
That's the big question. If we can crack that code, it would change the way we develop AI. We could allocate resources better, make smarter design choices, the whole shebang.
It would be a game changer for sure. Are there any other promising research directions you're excited about?
Absolutely. One that really stands out is the idea of combining different test time computing strategies.
So instead of using just one technique like repeated sampling or self-correction, we could have AI that uses a mix of different approaches, all working together.
Exactly. Imagine an AI that can brainstorm different solutions, critically evaluate each one, incorporate feedback from multiple sources, and systematically explore alternatives, all in real time.
That sounds incredibly powerful, like combining the strengths of different types of thinkers to create some kind of super intelligent AI.
It's a great analogy.
Yeah.
And the early research suggests that these hybrid approaches can really boost performance.
I'm really eager to see where this all leads. Test time computing, it's like a paradigm shift, right? It's not just about bigger models anymore. It's about making those models think smarter, more efficiently, and in ways that are more, well, human.
I couldn't agree more. It's truly a new era for AI.
And speaking of the human element, I think it's important to step back and acknowledge that we're the ones building these systems, shaping their development, and ultimately responsible for their impact on the world.
Absolutely.
Yeah.
We can't lose sight of the fact that AI is a tool. And test time computing, it's not just about making AI smarter for the sake of it. It's about making AI more useful, more reliable, and ultimately more beneficial for all of us.
Exactly. And that leads to some big ethical and societal questions. As AI gets better at reasoning and making decisions, how do we make sure those decisions align with our values, with what we want as a society?
That's the million-dollar question, and one that we all need to be thinking about. Researchers, developers, policymakers, everyone. It's not easy, but one promising approach is to build human feedback and oversight into the test time computing process itself.
So it's like having a human safety net to make sure the AI stays on the right track, that its decisions are ultimately accountable to us.
Exactly. For instance, you could have human experts evaluate the AI's reasoning, offer guidance during that tree search process, or build in mechanisms so that the AI knows when to ask for human input, especially when it encounters situations that are outside its training data or ethical guidelines.
That makes sense. It's about finding that balance between giving AI the freedom to learn, but also making sure it's ultimately accountable to us.
Exactly. It's a delicate dance, and it requires ongoing dialogue and collaboration between everyone involved.
Well said. I think it highlights how important it is to approach AI development with a sense of responsibility. We're creating powerful tools, and we need to do it thoughtfully and ethically.
I couldn't agree more. We have a real opportunity to shape the future of AI, and it's up to all of us to ensure that it's a future that benefits everyone.
Well, I think it's time to wrap up this part of our deep dive into test time computing. We've seen some amazing real-world examples, from visual tasks to language translation, and we've even glimpsed the incredible potential of LLMs. And through it all, we've emphasized the need for careful consideration of the ethical and societal implications.
We have covered a lot of ground, but this is just the beginning. The future of test time computing is brimming with both promise and challenges. And in the final part of our deep dive, we'll explore some of the exciting research directions that are shaping the future of this field. From the quest for more general-purpose AI to the complexities of multimodal reasoning and the relentless pursuit of efficiency, there's so much to look forward to.
I can't wait. But until then, I encourage everyone listening to keep thinking about this stuff, to ponder the possibilities of AI that can truly learn and reason in ways that we've only dreamed of before. Welcome back for the final part of our test time computing deep dive. So in the last two parts, we covered a ton of ground, right? We went over the basics, saw how this whole approach is already shaking things up in computer vision, language, all sorts of areas. But where's all this headed? What's the future of test time computing look like?
Nah, the big question. It's the one that keeps researchers and developers, well, let's just say, very busy. There's so much potential, so many avenues to explore.
Yeah.
We're really just getting started.
Well, I'm all ears. What are some of those exciting research directions you're most excited about? What challenges and opportunities are out there just waiting to be tackled?
Okay, well, one that's been popping up throughout our conversation, it's this challenge of generalization. Remember, we talked about how most AI, even when it's good at reasoning, tends to specialize in one type of thinking.
Yeah, like it might be a whiz at math, but then totally struggle with logic puzzles or something.
Yeah.
Unlike us humans, right? We're a lot more adaptable.
Exactly. And that's a big limitation if we want AI to truly be helpful in the real world. We need systems that can handle new situations, learn from just a few examples, and reason across different areas, like seamlessly.
So how do we get there? How do we build AI that's more of a generalist, ready to tackle anything?
Bill, that's the million-dollar question.
Yeah.
And there are no easy answers, but researchers are working on a bunch of interesting approaches. One idea is to design like more general purpose reasoning mechanisms.
Yeah.
Move away from those specialized architectures that are only good at one thing.
So instead of building AI like those specialized tools, each for just one job, we're trying to create something more versatile, like a Swiss Army knife that can handle a bunch of different tasks.
Perfect analogy. Another approach is to train AI on more diverse data sets. Expose them to a wider range of information, different ways of solving problems. It's
Yeah.
kind of like giving the AI a more well-rounded education, right?
Yeah, like the difference between reading one textbook and exploring a whole library full of different books and ideas.
Exactly. And then there's this really cool area where folks are trying to teach AI to learn new skills from just a tiny handful of examples. Kind of like how humans learn by watching or by analogy, you know. That ability to pick things up fast, it's crucial if we want AI that can keep up with the complexity of the real world.
This is all super exciting. Imagine AI that can reason across different areas, adapt to new situations, learn in the blink of an eye. It's like we're giving AI the same kind of flexibility that WE have as humans.
It's a really inspiring goal and one that's driving a lot of amazing research. For me, this whole pursuit of generalization, that's what's most thrilling about the future of test time computing. We're pushing the limits of what AI can do, and the solutions that emerge could really change the world.
I'm right there with you. But there was another challenge we talked about earlier, remember? Multimodal reasoning. That one seems, I don't know, both fascinating and a little scary just because of how complicated it is.
Yeah, definitely a tough one, but also incredibly promising. Remember, it's about going beyond just text, right? We're talking about AI that can integrate images, sounds, videos,
Yeah.
all into its reasoning process, giving it a more complete picture of the world, kind of like we have.
Right. We use all our senses to understand the world, and if we want AI to be truly intelligent, it needs to be able to do that too.
Exactly. Multimodal reasoning, it's about giving AI that same holistic, human-like understanding. But man, it's a huge undertaking. Conceptually, computationally.
No kidding. How do you even start to teach AI to understand something like a video with all the different layers of information going on?
Well, one approach is to kind of team up different types of AI, each a specialist in processing a different kind of data. So you might have a language model for text, a computer vision model for images, an audio processing model for sound.
So it's like assembling a squad of AI experts, each one bringing its own unique skills to the table.
Right. And then the trick is to figure out how to make those different models talk to each other, share information and insights so they can build a more complete understanding.
It's like having different teams in a company all working together to solve a big, complex problem. But I can imagine, with all those models and data streams running, wouldn't that be super demanding computationally?
Yeah, you're not wrong. Multimodal reasoning takes a lot of horsepower. So efficiency is super important. Researchers are looking at things like model compression, which shrinks AI models without sacrificing too much performance, and hardware acceleration, which uses specialized chips to speed up all those computations.
So we're optimizing both the software and the hardware, working on both sides to make multimodal reasoning more practical.
Exactly. And this whole focus on efficiency, well, it actually connects to another crucial area of research, scaling laws.
Ah, those again, we keep coming back to them. They describe how AI performance changes with things like model size, training data.
Right. Bigger models, more data, usually equals better performance. But with test time computing, the big question is, are there similar laws that govern how much extra compute we need during testing to get those sweet performance boosts?
So, if we give AI more time to think during testing, can we accurately predict how much better its answers will get?
That's the dream. If we can unlock the secrets of those scaling laws for test time computing, it would be huge EE. We'd be able to build and deploy AI systems in a much smarter way.
It would definitely change the game. And having that knowledge would be super helpful for all aspects of test time computing, right?
Hmm.
From generalization to multimodal reasoning, everything.
You got it. It's a really exciting area of research.
I'm really starting to see just how much potential this whole area has. But before we wrap things up, I think it's important to bring it back to the human element for a second, you know? After all, we were the ones building these AI systems, shaping how they develop, and ultimately, we're responsible for what they do in the world.
Could agree more. It's so easy to get caught up in the technology. But we can't forget that AI is a tool. And test time computing, it's not just about making AI smarter for no reason. It's about making sure that intelligence is beneficial, that it helps us, that it makes the world a better place.
Exactly. And that means thinking carefully about the ethics, about the impact on society. As AI gets better at making decisions, how do we make sure those decisions align with our values? How do we prevent bias from creeping in or accidental harm?
Yeah, those are big questions, and there are no easy answers.
Yeah.
It's something that everyone needs to be involved in, from the researchers and developers to the policymakers and the public. It's a shared responsibility to make sure AI is developed and used in a way that benefits everyone.
I totally agree. It's about finding that right balance, giving AI the freedom to learn and grow, but also making sure it's accountable to us, to our values, and to the well-being of humanity.
Well said. And I think that's a great note to wrap up our deep dive on. Test time computing, it's a fascinating field full of possibilities, but it also comes with a huge responsibility. It's up to all of us to shape the future of AI and make sure it's a future we can all be proud of.
I couldn't have said it better myself. It's been a wild ride exploring all these ideas, and I hope everyone listening is feeling as inspired and excited as I am about the potential of test time computing. Who knows what amazing breakthroughs are just around the corner? And as we move forward, let's remember to keep asking those tough questions, those ethical questions, to ensure that AI remains a force for good in the world. Thanks for joining us on this deep dive, and until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.